Yeah. Good evening, my dear students. In this video, I am discussing the detailed solution of rotational motion, or sometimes it is called as a rigid body motion also. Okay. First question, you read it. A constant torque of 1000 Newton meter turns a wheel of moment of inertia 200 kg meter square. Here, what are the given parameters? Torque equal to what? 1000 Newton meter. Okay. And then moment of inertia equal to 200 kg meter square. Okay, fine. Find its angular velocity after t equal to what? 3 seconds. That is what? We know the equation, that is omega final equal to what? Omega initial plus of what? Alpha into t. We know this. But in this problem, initial omega I equal to what? 0 case. We know this. But here no, I want to calculate omega f, but to calculate this I need what? Alpha, that is. One should think it, to calculate alpha, how to calculate alpha value, that is alpha value. Here we know the equation torque equal to, we know this equation I into what? Alpha. Therefore alpha equal to torque divided by what? I. Substitute this. Torque value is how much? 1000, and divided by moment of inertia equal to how much? It is 200. So that these two cancels, so that it becomes what? 5. What is alpha? Alpha equal to 5 radian per second square. Now I will calculate omega f. I will calculate omega f equal to 0 plus 5 into time is how much? 3 seconds. Okay, this is equal to omega f equal to 15 radian per second. This is the right answer. 50 radian per second. Next question. In rotational motion of a rigid body, all the particles move with same linear velocity and angular velocity, same linear and different angular velocity, with different linear velocity and same angular velocity. Here the right choice is this. We know that equation V equal to R into what? Omega, that is. Here, let us consider one rigid body. You consider, that is one rigid body. Okay, this is the rigid body you consider. Here, this body is what? Rotating, that is what? Rotating from point A to what? B. It is rotating like this. This is the angle theta. This is the angle theta. About this point it is rotating. Now I will consider one point. I will consider, that is now A1 B1. I will consider A1 B1. This is A1 B1. Okay, this one. Next, another one A2 B2 I am considering. Here you see the angular velocity for A1 B1, angular velocity A2 B2, it is same, because theta is what? Same here. We know that omega equal to what? Theta divided by what? T. T is the time taken. And then, but this distance is there. No, that is distance R will be what? Varies. This distance is varies. Here it is what? R1. This distance is what? R2. This is. The distance R changes here, so that as distance R changes, then velocity is also what? Changes. That means linear velocity changes. Linear velocity changes. Changes from one particle to another particle. Suppose if I consider this particle here, from A3 B3, that is I will consider A3 B3. Here the distance is what? It is R3. But of course, this omega equal to theta by t is same for all the particles. Next. A wheel of radius 1 meter. A wheel of radius 1 meter rolls forward of a revolution on a horizontal ground. The magnitude of the water displacement is asking. The magnitude of displacement. The same question already discussed in the displacement. Motion in one dimension discussed here. Okay, let us consider this one. Here I am considering one circle I am drawing. That is what? A circle I will draw it. Okay, now shapes. Okay. can't write. Okay, no problem with this. Okay, now I will draw a circle on this. This is the circle. This radius is what R. The radius of the circle is what R. I will call it at this point as A. I will call it as A. I will call it as A. This point is A. This point I will call it as a what? B now. Now this will be moves in the forward direction, that is moves forward off of the revolution, that is off of the revolution means here this point becomes A and this point becomes what? B now, that is. For one complete circle it is 2 pi r. For only off circle it is from here to here, distance equal to what? Pi into what? R. And this is the initial position and this is the what? Final position. Student, you see that is from A to B, the distance between A to B is what? This distance is what? 2r. What is displacement? Displacement is equal to the distance between the final position and what? Initial position. It looks like a parabola, that is what? Triangle. This is what distance is asking. A, this is what? A. Okay. A dash I will call it as. This is I will call it as a what? B dash. This will be what? 2r. This will be what? Pi r. So that using Pythagoras theorem, this distance displacement equal to square root of pi square into r square plus of what? 4r square here. Pi square plus this one is. Okay. Now here r is the what? I will take it r outside, equal to pi square plus of what? 4 raised to what? 1 by 2, that is. Here something is missing. In all these cases the distance is what? Pi square plus 4 into what? This is the right equation. That is equation. Okay. You should multiply by actually it is what? R it is. Okay. Next. A circular thin disc of mass is 2 kg has a diameter is 0.2 meter, m equal to 2 kg and diameter equal to, that means the radius equal to 0.2 by 2 equal to 0.1 meter. Calculate its moment of inertia about an axis passing through edge and perpendicular to the plane of the disc, that is perpendicular to the plane of the disc is SK. Perpendicular, that is okay, like this, and this is perpendicular. This is the diagram. This is the what? Axis. Moment of inertia about the axis x dash passing through its center and perpendicular to its plane equal to, that is we know that I x dash equal to, for the ring it is what? M r square, we know this. But now he is asking through the edge perpendicular to the plane. Edge means what? This is the edge. This is the edge. This is the edge. This is the edge. This is what? PQ. And this distance is what? R here. So that moment of inertia about PQ, it is a parallel axis theorem, you have to apply it. So that I x dash plus M into what? R square. What is I x dash equal to what? M r square plus of what? M r square equal to 2m into what? R square here. 2m r square. I PQ equal to, okay. Substitute this 2 into, what is the mass here? 2, that is into. Radius is how much? 1 is square it, 1 into 10 to the power of what? Minus 2. This becomes 4 into 10 to the power of what? Minus 2. 4 into 10 to the power of minus 2. Am I made any mistake? M r square. It is passing through Okay, thin disc now. Okay, I made mistake here. It is not ring, it is what disc it is. So that this becomes mr square by 2. Mr square by 2, nothing but how much it is? Equal to 3 by 2 mr square. It is a disc, it is. It is a disc, it is. Okay. This is equal to 3 by 2 into mass is how much? 2 into what? 1 into 10 to the power of what? Minus this 2 get cancels, equal to 3 into 10 to the power of minus 2 equal to 0.03 kilogram meter square here, kg meters. So that B is the right choice. Next. Radius of gyration of a body depends on mass and size of the body, mass distribution and axis of rotation. This is the right choice. It is the right choice. Next, sixth one is 3 rings, each of mass is m and radius r, are arranged as shown in the figure here. The movement of inertia of the system about y dash is okay. I will call it as a ring. This is 1, I will call it as this. I will call it as a ring 2. I will call it as this. I will call it as a what? 3. That is okay. Now here moment of inertia I equal to I1 plus I2 plus of what? I3. This is for I1 now. For the ring 1, it is about its diameter. About its diameter means we know that m r square by what? 2. We know this, m r square by 2. But for second ring, what happens now? It is like this. This becomes a tangent for the ring 2 it is. Now you have to apply the parallel axis theorem. You have to apply it here. Parallel axis theorem. For the parallel axis theorem, it is like this. So that this is be PQ equal to I PQ equal to, this is x dash, I x dash plus m into what? R square. This is the distance r here. I x dash nothing but what? About its diameter, that is. About its diameter, we know that m r square by 2 plus of what? M r square. This value becomes 3 by 2 m of what? R square it becomes. So that 3 by 2 m r square. The same story for this thing also. For this thing also, this will be the what? Tangent. So that plus of what? 3 by 2 m r square. Students, you see, which is the common factor in all these cases? That is m r square by 2 is the common factor. That is m r square by 2 is the common. 1 plus 3 plus of what? 3 here. So that the answer it becomes what? 7 by 2 of what? M r square. Is that choice? Okay. This is D is the right choice. Next. So the moment of momentum is called angular momentum. It is called as an angular moment. Angular momentum, we are writing like this: mv into what? R, or L equal to P into what? R. Sometimes it is called angular momentum, or else moment of momentum. That is also called moment of momentum. Next, the rotational kinetic energy of body is E and its moment of inertia is I. The angular momentum is the angular. Remember students, in the translation motion I told you, that is kinetic energy equal to P square divided by what? 2m. P equal to square root of 2m into what? K here. This is the story in case of what? Translational motion. It is in case of what? Translational motion. Translational motion. Many a times I discussed this one. But in case of rotational motion, the P equivalent term is what? L it is. P equivalent term is what? L. So that L equal to square root of M equivalent term in rotational motion I, 2 I into what? K here. So that this will be 2I into K or E, you can write it, or sometimes they will write it is what? E also they will write. So that this is the what? Right choice. 2I into what? E. Either you can write E or else you can write K also. Next. A force F equal to xi plus 3j plus 6k is acting at a point r equal to 2i minus 6j minus 12k. The value of x for which angular momentum about the origin is conserved. Okay. Here L is conserved. L conserved means L equal to r cross p must be equal to 0. Remember, indirectly it is nothing but 0. It's conserved. Angular momentum is conserved. Okay. Angular momentum is conserved means torque equal to d by dt of L equal to what? 0. That means net torque acting on the body is equal to 0. That is, when the torque equal to 0 means L is conserved. L is conserved. Remember this point. Indirectly is given torque equal to what? 0 here. It is sorry, not L equal to R cross P. Here, wait on this. This torque equal to rate of change of angular moment. We know that similar equation, Newton's second law. F equal to d by dt of P, rate of change of angular momentum. If momentum is constant, P is constant. If P is constant, differentiation of this quantity equal to what? 0. That means F equal to what? 0. Similarly, here also, if L is constant, means the differentiation of this quantity equal to what? 0 here. This is the story. Now, I have to calculate torque equal to R cross F. We know this. This is equal to I, this is J, this is what? K. Okay. R value, right? R value, this is 2 coefficient. This is minus 6. This is minus 12. This is X. This is 3. And this is what? K. 6. Now, this must be equal to 0 actually. This is torque equal to, okay. Now, I component. Now, you know this, minus of 36. That is plus of what? 36. Okay. Next, minus of J. This one is 12. And this is what? Plus of what? 12x. Plus K component. This will be 6 plus of what? 6x equal to 0 here. Tell me now. Of course, this component is 0 here. This component is 0. This is 0 is possible. 0 equal to 0 when x equal to what? Minus 1 here. You see? Here also, this term is 0 when x equal to what? Sorry, x equal to minus 1. So that this is the what? Right choice. Next, 10. Two rotating bodies A and B of masses m and 2m with moment of inertia Ia and Ib. Okay. Two bodies are there, moment of inertia Ia and Ib. Ib is greater than Ia. Okay, yes, given that is. Have equal kinetic energy of rotation if LA and LB equal to what? Just now I discussed, no? P equal to square root of 2m into what? E. Similarly, L equal to square root of 2I into what? E. Okay. Here in this case he has given kinetic energies are equal. The kinetic energy are equal. He has given, that is, which is quantity equal? Kinetic energy are equal. So that eliminate this. 2 is also constant. So that L is directly proportional to what? I. But already he said that IB is greater than what? IA. When I is greater, certainly LB is greater than what? LA. So that this is the right choice. choice. Next. Two bodies with moment of inertia I1 and I2 such that I1 greater than I2 have equal angular velocities. Okay, you see, equal angular velocities. If their kinetic energy of rotation are E1 and E2, that is. Okay. Now, we know that equation kinetic energy equal to half 1 by 2m into what? V square. Okay. The equivalent term in the rotational motion of I into what? Omega square. This is the equation. This is the equation in case of rotational motion here. Okay. Have equal angular velocity. That means omega is same. 1 by 2 is a constant. So that kinetic energy is directly proportional to what? R. That is kinetic energy directly proportional to what? R. So that since I1 is greater than what? I2. When I is greater, kinetic energy is greater. So that E1 is greater than what? E2. So that E1 greater than E2. This is the right choice. Trust. If rotational kinetic energy is 50% of translational kinetic energy, then the body is, that is what? Then the body is what he is asking. Okay, fine. We know one formula I given in the regular class also. Rotational kinetic energy divided by translational kinetic energy, translational kinetic energy. There are three formulas are there. Equal to k square divided by what? R square. Okay, fine. But in the problem he has given the rotational kinetic energy is 50% of translation. That means that is 50% of this value. That is rotational kinetic energy divided by translational kinetic energy equal to k square divided by what? 50%, nothing but 50 by what? 100. That means 1 by 2 equal to k square divided by what? R square. Recall it. K square by R square equal to 1 by 2 for which value? Either for the disk or else what? Solid cylinder. It is what? Solid cylinder. It is what? Solid cylinder. Disk is there? No. But solid cylinder is there. So that this is the what? Right choice. This is important, students. K square by R square equal to what? If you are getting 1, it should be what? A ring. And then K square by R square equal to 2 by 3. It is what? Hollow sphere. Then k square by r square equal to 2 by 5. It is what? Solid sphere. I told you several times in the regular class. 13th. If the angular moment of rotating body about a fixed axis is increased by 10%. Okay, fine. Angular momentum is increased by how much? 10%. Its kinetic energy will be. Now you have to connect the relationship between the kinetic energy and angular momentum, that is. Recall it. Kinetic energy equal to, in translational motion, p square divided by what? 2m. In rotational motion, kinetic energy equal to L square divided by what? 2I. This equation we know that. Students, you see here, only the variable quantity is what? Angular momentum. Only variable quantity is here. So that you don't take. So that E is directly proportional to what? L square. E is directly proportional to L square. Here L increases by how much it is? 10%. I told you regular class, 10% nothing but 110 you have to take it. 20% nothing but 120 you have to take it. So that he is asking what is the percentage of kinetic energy will be what? Increases. So that E2 by E1 equal to L2 square divided by what? L1 square. This is equal to 110 into 110 divided by 100 into what? 100. Initial values. This 0, this 0, this 0, this 0. We are getting what? 121 divided by what? 100 equal to 1.21. In terms of percentage, it becomes how much? 21%. That is what? It is the right choice. Change is asking. Change is delta E. How you have to calculate? Equal to E2 minus of E1 divided by what? E1. You have to calculate like this. Okay. Now, this will be 21%. Because this will become 1.21 minus of what? 1 divided by what? 1. This becomes how much? 0.21. In terms of percentage, what you have to do is 0.21 multiplied by what? 100 you have to do it. This becomes 21%. Here in the shortcut method, no need of all these things are not required. Directly that is, you can do it. Okay. Next one. A thin rod of length is L and mass is M. Okay, this is the rod. This is the rod. Okay. This rod length is what? L and mass is what? M. Okay. Is bent at its midpoint. Okay, I will bend it like this. I will bend it in the L shape. That is what? Bent. Okay. The moment of inertia of the bent rod about this axis is asking. Student, you see, this is L by 2. This will be what? L by 2. This is M by 2. This will be what? M by 2. Okay. Here, for the rod, we know that. For the rod, we know that. This I will call it as a rod 1. I will call it as a rod 1. This I will call it as a what? Rod. I total equal to I1 plus of what? I2. Of course, both are same. That is equal to 2I1 because I1 equal to I2. Okay, fine. We know that axis is here. That is, this is the x dash. It is nothing but like this. That is nothing but. This is P. This is Q. This is the what? The center. Here, what about this axis? Axis passing through its one end. This is what? Axis. What is the formula for that? Axis passing through its one end. We know that IPQ equal to ML square by what? 3. Formula we know this. ML square by 3. We know this. Now, here, 2 into M. What is M? M nothing but what it is? M by 2 it is. Okay, fine. L square by 3, it is what? 1 by 3. L means it is not L by 2 what? Whole square divided by 3. Followed or not? Because I already told you, this mass is M by 2. This length is what? L by 2. Here what is the formula? IPQ equal to what? IPQ equal to L square by what? 3. That is okay. Then this 2 is what? Get cancels. This becomes 4 tall. It is tall into bracket M into what? L square. Is there? ML square by 2. This is the right choice. Okay. The bent rod about an axis passing through the bending point. Bending point means this is the bending point. Okay, next. 15. A solid disc rolls clockwise without slipping over a horizontal path with a constant speed v. Then the magnitude of velocities at point A, B and C. Okay, listen carefully because this point I have not solved in the regular class also. I have not solved. Okay, fine. This is the surface. it as A, this point I will call it as a B, and this point I will call it as a C. Here when it is rolls down, it has got both translational motion as well as rotational motion. This is the translation. V. All particles are moving with the velocity V. This is velocity V. Okay, fine. This is pure rotation. This pure translation. It is pure translational motion. Okay. Plus, just like your bicycle wheel, that is. Another motion is that this is called as rotational motion. It is rotating like this. This point is A, this point is B, this point is what? C. Now it is rotating like this, so that this point at point C, it is like this. This point C, I will draw it like this. This is the point C. This will be omega into R, rotational motion. It is nothing but what? V. It is what? V. It is nothing but V. It is. Alright. At point, this point is also rotating. This is also what? V, that is. But what about at this point? It is rotating like this, so that it will be like this. It is like this. It is V, and this is what? V it is. Now you say, of course, I will undo it. Okay, undo it. Okay, this will be removed temporarily. Now it is together, it becomes what? What is this? Translational motion plus of what? Rotational motion. At this point, you say this will be V and V. It becomes 2V. It becomes 2V. What about, students, at this point? At this point, one velocity is like this and another velocity is like this, so that here it is what? 0. This is point A. This is point C. What about at point B? At point B, you see one velocity is like this, one velocity is like this, so that this is the resultant velocity. Resultant V R equal to square root of V square plus V square equal to square root of 2 into what? V. This becomes square root of 2 into what? V. What is the conclusion? At point A, 2V, where is that 2V? Possibility is either this possibility or this possibility. Okay, fine. And also what? This point. At point C, it is 0. 0 means what? Only this is the, so that this also situation. This is ruled out. Now I have to think it. Either B is right or C is right. Of course, at point B, it is what? Square root of 2 is there, so that the final answer is this. This is a translational plus of what? Rotational motion. It is rolling, that is, it is rolling without slipping here. Rolling without slipping. Of course, this point I have not discussed in the regular class. This important term. This is the important. Okay. Now, this is important question, student. So that the answer is what? Here it is at the point C is 0. Of course, here also 0. Here also it is what? 0. Here also 2V, 2V. You have to judge it by this point. Square root of 2 into V here. Next. A body is rolling down an inclined plane. Okay, fine. Its translation and rotational kinetic energies, actually it is kinetic energies, are equal. Your translational and rotational kinetic energies are equal. That means just now I saw, no? It is rotational kinetic energy divided by translational kinetic energy. Translational kinetic energy equal to, what is the formula? K square divided by what? R square. Here both are equally said that. Therefore, k square by r square equal to what? 1. 1 means it must be a circular ring. Or we can say that hollow cylinder. It is what? Hollow cylinder. So that which one? Hollow cylinder. This is the right choice. Next. A small object of uniform density, it is rolls up. Now it moves like this. Okay. With velocity v, that is. It reaches up to a maximum height. Has given this height has given. H equal to 3v square divided by what? 4g. That to reach this height, what should be the object? Is it ring or solid sphere or hollow sphere or this? That you can judge it only by the value of k square by what? R square. You have to judge it by this. Okay. Very interesting question that is. Here, according to law of conservation of energy, 1 by 2 into what? mv square, translational kinetic energy, plus rotational kinetic energy, I into what? Omega square equal to mgh. We know this equation. Okay, fine. Now, here 1 by 2 mv square, rotational 1 by 2 mk square, and v equal to, we know that r into what? Omega. Therefore, omega equal to v by what? R. So that this becomes v square divided by what? R square equal to mgh. Okay, fine. Which are the factor get cancels? This m, this m, this m is what? Get cancels. Now, what you will get here? 1 by 2 of what? V square plus 1 by 2 k square into what? V square by what? R square equal to gh. 2 I will multiply it on both sides. That means v square plus k square divided by what? R square into what? V square equal to 2gh. Which is the common, that is factor here? V square is the what? This one is. Okay. Now, h. Okay. V square is the common. V square into bracket 1 plus k square divided by what? R square equal to, h equal to, we know this, 2g into h equal to 3v square divided by what? 4g. Okay. Now, here, which are what cancels? You check it. This g is get cancelled. 2 1 ja, 2 2 ja, it cancels. That means, and this v square is what? Get cancelled. That means 1 plus k square divided by what? R square equal to, what is that? 3 by 2 is left. 3 by 2. This is 3. This is what? 2. Now, k square divided by R square equal to 3 by 2 minus of 1 equal to 1 by 2. 1 by 2 is there for which one? Disk. For disk. It must be what? Disk here. Because we got k square divided by R square equal to 1 by 2. It is possible for disk or solid cylinder. Of course, has given the disk. So that this is the right choice. Okay. 18th. A solid sphere, disk and solid cylinder. One is solid sphere, disk and solid cylinder. All of them of the same mass and made up of the same material are allowed to roll down on an inclined plane. This is the inclined plane. Okay. And this is the angle theta. One is what? Solid sphere. And another one is what? Solid cylinder is there. Cylinder is there. Okay. And another one is what? Solid sphere, disc, and this one is. Okay, fine. He is asking the question in choice. Which one will reach the right choice? Solid sphere will reach the bottom. Solid sphere reach the late. That means here we know that equation T is directly proportional to K square divided by what? R square. If T is less, then that particle will reach that particle or object particle will reach first. If T is less. But T is less if K square by R square is minimum. Okay. The minimum value, okay, for sphere, solid sphere, K square by R square equal to what? 2 by 5 equal to what? 0.4. Next, disk K square divided by what? R square equal to 1 by 2 equal to what? 0.5. Then solid cylinder is also same. Solid cylinder K square divided by what? R square equal to what? 1 by 2 equal to what? 0.5. Here you see K square by R square is minimum for this one. This is minimum. When this is minimum, T is what? Minimum. So that it must be a solid sphere reaches the bottom first. This is the right choice. Next. Two solid discs of radii R and 2R roll from the top of an inclined plane without slipping. Two solid discs. Okay. Here there is, remember, important point this one is. Here you are always which one will reach the first velocity. It all depends upon only the value of K square divided by R square. It is immaterial whether radius is R or 2R, it is immaterial. Its ratio is important. Both are what? Solid disk. Both are solid. One is what? Radius is what? R, and another radius is what? 2R. It is what? 2R. Don't think that it is different timings and all that. No. Here, the bigger disk will reach the horizontal level first. No. Both disks will reach the same time, student. Important point. It is immaterial of what radius it is there. Because as radius changes, the K value is also what changes. But however, the ratio remains constant. It is this ratio remains what? Constant here. I given the formulas: time for velocity, acceleration, and time period. Time I given the equation where all this depends upon only K square by what? R square only. Next. A disk and a solid sphere of same radius. One is disk is there and another one is what? Solid sphere. But of different masses roll down on two inclined planes of the same altitude and length. H is same, L is same. But different, same radius but different mass. It is immaterial. Radius also what? Immaterial. Only what is different? Important is K square by what? R square. Which one of the two objects gets to the bottom of the plane first? Again T is directly proportional to K square divided by what? R square. If K square by R square is minimum, if this is minimum, then T is also what? Minimum. T is also what? Minimum. If it is minimum, then it will reach first. It will reach first. It will reach first. It will reach first. There. For disk, k square by r square equal to 1 by 2 equal to 0.5. For solid sphere, k square by r square equal to 2 by 5 equal to 0.4. So that both solid sphere it will reach first. Next. When a solid sphere rolls without slipping, when a solid sphere rolls without slipping down an inclined plane making an angle of theta with horizontal, what is the acceleration? It is a1. That means without slipping means a equal to, we know this equation, a equal to g into sine theta divided by 1 plus k square by what? R square. What is the acceleration? a1 has given. a1 equal to g into, okay, angle has not given, sine theta divided by which one? Solid sphere. So solid sphere, k square by r square equal to 2 by what? 5. So that 1 plus 2 by 5. That means a1 equal to g into sine theta divided by what? 7 divided by what? 5. Am I right? This is equal to a1 equal to, therefore a1 equal to 5 by 7. 5 by 7 into what? G into what? Sine theta. This is equation number 1. Okay, fine. If the same sphere is slides, it is slides. Okay. This is the object on this. Here, object will be slides. We know this. This is the what? G. This is what? G into what? Cos theta. And this will be what? G sin theta. So that acceleration equal to a2 equal to g into what? Sin theta. This is equation number 2. Now he is asking the relation between the, which one is right, he is asking, that is okay, right? Now I will divide it. a1 by a2 equal to a1 by a2. Suppose if I divide it like this, now this get cancels, becomes 5 by 7 it becomes. So that a2 equal to, therefore a2 equal to 7 by 5 of what? a1. Is it right? 7 by 5 a1 is the right choice. Okay. Next, 22nd. The angular velocity of the second needle, that is angular velocity, omega equal to 2 pi divided by what? Equal to 2 pi divided by what? 60. This is equal to what? Pi divided by what? 30 radian per second. So that is the right choice. Next, 23rd. The wheel of a car is rotating. The wheel of a car is rotating at the rate of 1200 revolutions per minute. On pressing the accelerator for 10 seconds, it starts rotating at 4500 rotations per second. Okay, fine. The angular acceleration is, okay, alpha equal to, we know that omega 2 minus omega 1 divided by t. And we know that omega equal to, what is the formula? 2 pi into what? F. Then alpha equal to 2 pi into what? F2 minus F1 divided by what? T it is. Okay, fine. Now alpha equal to 2 pi. F is number of rotations per second, but it is not per second, per minute has given. 1200 minus of formulas 4500 divide, okay, 1 minute, final value you have to write it. Okay, alpha equal to 2 pi into 4500 minus 1200 divided by what? 60 students, whole divided by time equal to how much? 10 seconds. Do you know why I divide by 60? I converted per minute to what? Per second. Then finally they were getting alpha equal to 2 pi, correct? Into 4500 minus of what? 1200. I think it is 3300 divided by 60 into what? 10. So that this, what are some values are getting here, multiply by what? Degrees per second square. Degrees means you have to convert, it is what? 180 degree, 180 pi equal to what is this? 180 degree. Therefore for this here, that is, so that it becomes 180 multiply divided by what? Pi. That is, you have to do it, divide by pi, or 360 by 2 pi. Then if you translate this, you are getting 1980 degrees per second square. You will ask question, sir, why is it not radian per second? No, it will not get. If you do like this 0, this 0, this 0, this 0, you are getting 2 1 ja, 2 3 ja, 3 1 ja, 3 11. You are getting 11 pi radian per second square. There is no 11 pi here. So that this is not radian, this also what? Not 11. So that the possibility is either this or this. That's why I converted into what? Degrees per second square I converted. Next, 24. 4 thin rods of same mass and length form a square as shown in the figure. Okay, of course figure is not there. Now rods, it is like this. Okay, and each length is what? L. This is L, this is L, this is L. This rod I will call as a 1, this rod I will call 2, this rod I will 3, and this one I will call as a what? 4. That is. The moment of inertia of this system about an axis passing through its center, that is what? Like this. For this, for rod 1, I total equal to I1 plus I2 plus I3 plus of what? I4. But all are equal. So that can I write I2 equal to 4 into what? I have it right. But students, here about this axis means here you have to apply the theorem of what? Parallaxis theorem you have to apply it. 4 into m L square by 12. It is about its center. We know that for the rod about its center, this. But axis is what? This is x dash. But your axis is here. This is P. This is what? Q. And this distance you have to consider this. Okay, that will be L by 2. Then plus m into what? L by 2. This length is L by 2. Distance becomes L square by what? 4 it becomes. L square by 4. Okay. This becomes I equal to 4 into, okay, ml square by 12 plus this one, it becomes LCM. It is ml square by 3, I think. That is what? ml square by 3. If you want, you can calculate this part, you can calculate this part. M L square into bracket 1 by 12 plus 1 by 4. This is equal to M L square. LCM is 12. It is 1 plus 3 equal to 4 by 12. 4 by 12 M L square. 4 by 12 nothing but what? 1 by 3. That is what? That means ml 4 ml square by 3. I total equal to 4 by 3 of what? ml square. Is there choice? Yes, that's the choice. 25. An automobile engine develops 100 kilowatt power when rotating at a speed of what? 1800 revolutions per minute. What is the torque acting on it? Remember, students, always you correlate the relation between the translational motion and the rotational motion. In translational motion, power equal to work divided by time by writing. Yes. Work equal to, how you are writing? force into displacement divided by time. This is a story in case of what? Translational motion. But here it is a rotational motion, no? Where power equal to F equivalent term is what? Torque. S equivalent term is what? Theta divided by what? T. Here you see, what is theta by T? Power equal to torque into what? Omega. All the time we can't remember all the formulas. Just within 2 seconds you can translate this. He is asking torque. He is asking torque equal to power divided by what? Omega. Yes. What is the power? 100 kilowatt. That means 100 into 10 to the power of 3. Omega equal to 1/800 divided by what? 60 it is. Divided by 60. So that these two get cancels. This becomes 1000. Okay. Into what? 60 divided by what? 18. That is what? That means it is 6 into 10 to the power of 4 divided by 18. 6 1 ja, 6 3 ja. 1 by 3 into 10 to the power of what? 4. That is roughly, it is all together just to translate. Then you are getting 531 Newton meter. This is the right choice. No, at a speed of F is given. Okay, multiply by what? 2 pi for button here. 1 minute. Okay, here power equal to how much? 100 into what? 10 to the power 3. It is omega equal to 2 pi into what? F. This is equal to 100 into what? 10 to the power of 3. 2 into pi into F equal to 1800 divided by what? 60. That is because it is F is given in per second. I need know. That's why this. Then you are getting 531 Newton meter. Next, 3 identical spheres, each of radius r, are placed touching each other on a horizontal table as shown in the figure. The coordinates of the center of mass, I will extend it like this. This I will call it as a M1, this I will call it as a M2, this I will call it as a what? M3. That is. Okay. Write the coordinates. M1 coordinates are 0, 0. This is the 0, 0. Then M2 coordinates are what? X coordinate. You see, you are traveling from this point to this point. This is R, this is R. So that it becomes 2R, comma what? 0 you are traveling. Okay, fine. What about this M3? That is here. Now I will draw like this. You need this coordinate. Of course, here for M3 coordinates are from here to here. X coordinate is R. What about Y coordinate? It is like this. Here this distance is what? 2R. This distance is R. I need what? A, B, C, S. That means AC square equal to AB square plus BC square. What is AC square? 4R square equal to AB square plus of what? R square. Simplify it. AB square equal to 4R square minus of R square equal to 3R square. Therefore, AB equal to square root of 3 into what? R. This is the coordinate. Square root of 3 into what? These are the coordinates. Once you are able to find the coordinates, nothing in it. Okay, I will repeat this portion. Then x of coordinate, x equal to, we know that formula, m1 x1 plus m2 x2 plus m3 into what? X3. Next, divided by m1 plus m2 plus of what, m3. Then x of center of mass equal to, okay, what is m into x1 is 0, this is 0, plus m x2 means this one is 2r, plus m3, it is what, m into x3 nothing but what, r, divided by all masses are same, it is 3m. So that this quantity will be what, 0. So that this becomes 2mr plus mr, x of cm equal to 3 of mr divided by 3m. So that 3m get cancels. What is left? R. R means this is not possible, this is no. Either A is right or else what, D is right. Still I can't draw the conclusion. Okay. Now this is x coordinate. Next, y coordinate, same thing, y of center of mass equal to y1 into what, m1 plus m2 into what, y2 plus m3 into what, y3 divided by m1 plus m2 plus of what, m3. Yes, write it. What is y1? This term is 0 into what, m. Second is, it is also 0. 0 into what, m plus m3 m. y3 is how much? Root 3 into what, r divided by what, 3m here. This term is net 0, this term is 0, so that this m get cancels. So root 3 by 3 into what, r, or else we can write r by what, root 3, that is r by the root 3. That means this is the right choice. 27. 3 particles of mass 1 kilogram, 3 by 2 kilogram and 2 kilogram are located at the vertices of an equilateral triangle. That is what? Equilateral triangle. Okay. Right. This is 1 kilogram. This is 3 by 2 kilogram. And this is what? 2 kilogram. Okay. Are located. And each side is what? This is A, this is A, this is what? A. Okay. Now, the coordinates of this is 0, 0. This about this point. The coordinates of this is A, what? 0. I told you in the regular class, this coordinate is what? One is A by 2, A by 2. Y coordinate, how to calculate y coordinate is like this. A, B, C. I need this quantity, I need. This angle is what? 60 degree. So that tan 60 equal to AC. This is AC, this quantity. Divided by what? This one. It is A by what? 2. Therefore, AC equal to tan 60 nothing but what? Root 3. Yes, into what? A by what? 2. So that this end, root 3 by 2 A. These are the coordinates. Once you are able to find the coordinates of each mass, okay, each mass here. Here one mass is a second mass, and this is what? 3 mass. Okay. Now, you have to usual method, you follow it. That is xcm equal to m1 x1 and all that. Then you will get here, it is x of center of mass equal to m1 x1 plus m2 x2 plus m3 x3 divided by m1 plus m2 plus of what? m3. Substitute this. 1 into what? 0 plus this is 3 by 2 into what? A plus 2 into what? A by what? 2 divided by all the masses. 1.5, 1.5, 1.51, 2.5. This becomes what? 4.5. It is becomes 4.5. 4.5 and all. Then simplify it. X of Cm equal to 5 by 9 of what A it is, 5 by 9 A. So that this is not, then 5 by A by 9, either this is right or else what, this is right. Okay. Similarly, YCM you have to calculate using the formula M1 Y1 plus M2 Y2 plus M3 Y3 divided by M1 plus M2 plus of what, M3. By simplification, YCM, I will not go detail, this becomes 2A by 3, that is 2A divided by 3 root 3, these are the coordinates. 2A by 3 root 3 means this is the right choice. Yes, next. 28. 4 particles of mass M, 2M, 3M and 4M are placed at the 4 corners of a square of side is what, A. Okay. Now I will tell you the easiest method, I will tell you, that is, okay, this is M, okay, this is what, 2M, this is 3M, this is what, 4M, or you can say that 1 kg, or else I will consider it as a 1 kilogram, 2 kilogram, 3 kilogram and 4 kilogram. Consider this side is A, this side is what, A. I will tell you one easiest method. These two masses, you join it like this, it becomes what, 3 kilogram or 3M it becomes. Similarly, this one also you join it, this becomes 7 of what, M, and distance between them is how much it is, A is there. Student, you say the heaviest mass is 7 is here, that is, so that the center of mass will be lies here, very close to what, 7, that is, very close to 7 kilogram. Very close to 7 means it may be either this possible or this possible. Now let's check it. Okay, this is possible or this is possible. No need to detail, is not required. Okay, or else I will assume that this is 3M and this is what, this is 3, this is what, 7. Whole distance is what it is, A. Here I will consider this is X, I will consider this will be A minus of X, and we know that 3 into A minus of X equal to 7 into what, X. Simplified, 3A minus 3X equal to what, 7X. Therefore 3A equal to what, 10X. Therefore X equal to 3 by 10 of what, A. 3 by 10 A. That's why I told you, either this or this. 3 by 10 nothing but 0.10. Okay, this is 1. Still it is, I can't judge it whether A is right or this one. Now I will club it like this, I will club it. This becomes 5, that is, this is 5M. Similarly, this and this you club it, this becomes, this also what, 5M. Both are equal now, both are equal. What is the distance here? A. Then both masses are equal, so that it is off. It is what? Off. Off means what? A by 2 it is. A by 2. A by 2 directly it is not there. It is 5A divided by what? 10 equal to A divided by what? 2. So that this is the right choice. Next, 29. 5 uniform circular plates, each of diameter D and mass is M, are laid out on the pattern shown in figure. Using the origin shown, find the Y coordinates. Okay. Now I will name it M1. This I will name it M2. This I will name it M3. This will be M4. This will be M5. Write the coordinates. M1 coordinates, it is the origin only, 0, 0. M2, you see, for this, X is 0, but M2 equal to coordinates are from here to here. Is it not diameter? It is. This is radius, this radius, 2 times radius, nothing but it is d comma 0. Next, for this disk from here to here, this is one diameter, this is what? One diameter. It becomes two diameter. M3 equal to 2d comma what? 0. Okay. What about M4? From here to here, it is what? M4. M4. Here. M4. Yes, write as M4 coordinates. Here it is M4 and this one. M4 is from here to here, it is what? Diameter. Y coordinate is what? 0 for this. But what about for this? You have to travel like this and you have to travel like this, so that M5 coordinates are d comma d. It is d comma d. The usual method, you apply it and then do it here. This will be the C will be the what? Right choice. I think out of that you will do this. And so this problem I did in the regular class, 30th. The center of mass of a system of two particles of mass m1 and m2 is at a distance d1 from m1 and distance d2. Yes, what now? This is m1 and this is what? m2. Okay. One center of mass is here. What is this distance? d1 is that. The next, this distance is what it is? d2 is that. We know the formula, m1 d1 equal to m2 into what? d2. That is. Here d1 divided by d2 equal to m2 divided by what? m1. That is. So that d1 by d2 equal to m2 by m1. This is the right choice. Okay students, now I will stop at this. Yeah.